Welcome back to our Learn to Rank session for another talk about Learn to Rank framework, farm your ranking models from OLX, presented by Ilan Dubois and Marcin Gumkowski. So you're welcome.
All right. Hi, everyone. So I'm Ilan, and this is Marcin. And today is a presentation that does a bit of follow-up of a presentation that was done in the Haystack, and that introduces the new topic we have been working on and how did we decide to work on those topics. So presentation of me, I'm from Normandy. If you watch Lupin on Netflix, then that's where they end. And yeah, and then Marcin.
Yeah, that's me. Marcin, I'm from Poznań. This is the place between Berlin and Warsaw, famous from St. Marcin croissants. Yeah, that's me. But I wanted to also present the whole team. Katarina, our data scientist, Katarzyna, our data product manager, and our data science manager, Christian. We work together on this project. So, agenda for the presentation today. First, I will introduce OLX Group to all of you because you might don't know the platform. Quickly intro about learning to rank because we already had it in the previous presentation. Challenges that we facing in a OLX Group, which are different than what we saw in the previous presentation. We will tell you a bit about LTR Framework, and the second half of the presentation will be about the business use cases, where we use the framework, and this helped us to solve these problems. So first, yeah, we are OLX Group, quite a big company. We are in several markets across Europe, like starting from Portugal, Poland, Ukraine, but also not only Europe, Kazakhstan and Uzbekistan. So you see the diversity of those markets. It's not only Europe, as I said before. What's more, these platforms are classified, but it's not only general classifieds. It's also, for example, automotive classifieds, real estate classifieds, jobs classifieds, services classifieds. So we call it this verticals. So different platform, different use cases for search. This is very important to understand why we built LTR framework. Learning to rank algorithm, right? This is again the repetition. In our case, it's in most cases, this is a query plus some filters as an input and extracted documents from the search engine. In our case, it's a Solar. We, yeah, pass those input to our LTR model, and we re-rank documents, and then we serve to our users. On our platform, user signals or relevant signals, they are quite different than what we saw on the previous presentation. We have, in my opinion, they are more stronger, but not strong enough as I know on the e-commerce platform, typical e-commerce platforms. We have signals like favorites, right? Clicking on favorites so user can interact with the ad. We have a deliveries for some used items. Also, we have an interaction with another with a seller, right? So our buyers can send a message, can call, right? So every those interactions, these are some sort of the signals, relevant signals. And we also, we don't treat them equally, right? For example, favorite, it's a very strong signal, right? But just showing the phone number, not necessarily. Usual LTR pipeline in our case, before LTR framework. So it was our data. We have another teams responsible for our click stream. We store it in data lake, but we process the data sets for the need to train a model with a Trino or Spark. Depends on the platform. Bigger platform, then probably will take a Spark. Smaller, then Trino is good enough. Then we train models. Again, depends on the platform. We use several libraries like XGBoost, CADBoost, LightGBM. Sometimes it's like I will describe it in at the end of the presentation, but there are some other wrappers around the models. So it sometimes it's varies basically. And then we save models in some model registry where we can send them to our search engines. Luckily, all search engines, these are Solars. So at least this thing, it's common for all platforms. Now I will tell about 3 challenges in OLX group that we face building the LTR in general, right? The first, and this is, I think, the biggest one, the number of targets to optimize. We, on our platforms, let's take a general classified, so used items. We have listings with, let's say iPhones. We have so-called VAS, I don't know, is it visible? Not sure, right? Okay, we have ads which are VAS types, value added services. So basically people paid us, right, to increase visibility of their ads. And we have at least 2 types of VASs. Then we have organic ads. So these are free ads that people posted on our platform. Also, we have a delivery ads, right? That you can order to your home, right? By clicking and making an order on the platform. So without any human interaction, real human interaction. So in the business, we have to optimize not only for a just single relevance score, but multiple targets. That's the main problem. Somehow we managed to solve this problem or make our business happy. So we rely on multi-objective optimization. And on the y-axis, we have a NDCG for VAS ads, so paid ads. And on the bottom axis, it's organic ads, so those ads that are free. And by the blue dots, these are the models that we train with the different parameters of the algorithm. And then we can build a frontier line. And by moving on this frontier line, we can decide what's the acceptable trade-off for the business, right? Probably, if we want to be more sustained, then we want to, I know, probably go, we want to get more money, then we can go a bit upper with the VAS ads, right? If we want to satisfy our buyers, right, with pure relevancy, then we will go this way. Another challenge is the multiple models that we have to train. As I said, multiple platforms, but it's not only multiple platforms. We have several categories in general ads. Very often we see the different behavior in the data sets between keyword search and category browsing. Like people for automotive, when they looking for a car, they don't use keyword search as often as on general classifieds. So category browsing, it's more likely to happen on platforms like real estate classifieds, what else? Yeah, motors, so automotive classifieds, things like that. But keyword search happens more often on general classifieds when you want to find I don't know, clothes, bikes, things like that. And what else? So different platforms, but also many countries. So these models, the number of models is pretty huge. And the last challenge is the number of pipelines and the maintenance of them, right? So every platform, every category, it's a different pipeline that we have to maintain. There are only a few engineers that know those pipelines, and the time that they were spending on fixing, especially this part, the input of the data, sometimes it was very overwhelming for us. And we realized that we quickly started using 3 buttons, Control-C, Control-V, for duplicating these pipelines. So the main drivers for LTR framework why we started the project, right? That duplicating efforts. We saw that technical debt started growing. We work in different teams, but on the same problem. So maybe there is a synergy that we can create in this project. The lack of the speed of the cycle for the experimentation, that was the one of the reasons that business wanted us, right? You have to be faster in the iterations, but also we also observed that. And at the end, maybe we can cut some costs.
All right, so I'll go quickly over the solution that was described already last time. So now we have a unified tool that allows us to do all of that. So we have different pipeline to ingest the data, and then the tool can shape a lot of model flavors. I think within OLX now, so within just the classified websites, we have about 60 or 70 different models being served at any point in time. And long story short, the good solution was Hydra. It's the Meta AI library for configurations. In the end, it works really well. So yeah, so for instance, we have those 3 units, as we said. We can have multiple targets. We have to always serve several countries. We can have many different things that change. And we wanted to increase flexibility to try, mostly for experimenting way quicker, and that it would take less resources to try and experiment something. When I say experiment, I mean A/B testing for us, that's what it means. And better organization. I'm not sure what they meant here, but I guess it was better. And then new features to the data set. Yeah, that's 75% faster. I would say in general, the idea now, if you have an idea and the data scientist in the notebook writes something and wants to try the model for A/B tests, from the notebook to we started the A/B test, now we can do it in an hour. In the past, it was at least a week or something like that. So it's much faster. The only issue is more adding the new feature into the pipeline. So we have to make sure that when they want to start, sometimes we have some engineering to do ahead of time. So we are very happy with the performance. As you can see, all of green marks, especially for the duplicating efforts. And we stopped growing tab tag. As you can see, we said we stopped growing. We didn't eliminate it. We are very accurate there. Yeah, rapid experimentation. I forgot what was the number Anderson said, but it was quite high just on the motors business, even though in the past it was like once per quarter. Now we do
One quarter we did what we last quarter we did what we done it in 9 months.
So times 9. All right. So now this is an interesting plot we had from our PM, and we were trying to see what we can improve. So here, unfortunately, I'm not sure you can see so well, but we have the number 1 point here. That would be freshness sorting. That's what we were doing before. Thanks. And basically what it means is once you write your ad on OLX, it will show at the top at the beginning. When you promote it, we push it at the top again by just cheating on the creation date. We just lie, we say, oh, it was created now. That's all that was happening. So that's called freshness sorting. So it's very good for the VAS performance. Our sellers are happy, but the customers do not have the best experience. The alternative would be to do an LTR based on pure relevance. So with as many features as we want, but just focusing on how many meaningful interactions we have. So there, the buyers, they will be happy, but our bottom line, we wouldn't be happy, right? We need to make money. And the VAS LTR, this is the solution we got with this Pareto frontier Marcin was showing you before. This is kind of choosing where we want to set the balance. And that's what we are doing most of the time, basically trying to set the balance. The balance can change depending on the category, depending on our priorities. Now we even experiment not looking at the VASes in real estate, but we want to look at the ad quality data because we have some SEO issue. Better ad quality would mean we are better in SEO. So we can also optimize for different things. Let's skip that one, that's gibberish. Let's look at this one. So now Marcin is going to present you the kicker in Motors. That's the name of the tool you want to create to allow business people to set exactly where they want to be in the relevance to VAS scale. So it's going to show you how it works. But basically, we are here and we want to be able to set very finely and change it through time, how it works depending on the category, etc. And now I will present you the personalization for us as we work on it. We just want to increase performance, and then that will be the work of the kickers to decide on the trade-off to make. For personalization perspective, I just want to increase accuracy, basically, relevance. So those are the two business use cases we want to talk about. Okay, so one problem is the disambiguation. As we have seen before on OLX, one that works really well, especially in OLX Poland, is golf. If you look for a golf, you will get a car, some wheels, some golf clubs, and in Polish, golf also means turtleneck, right?
Turtleneck.
So you will also find turtleneck sweaters in our search results. Not great. Personalization will help you with that because if you have already bought a golf cart, maybe you want to see those. If I don't know which ad you would need to see before. Maybe if you look at a bunch of other brand cars. Okay, so here are some examples where we want to be useful with this. So as I said, the golf, it's more to disambiguate. If you look for bike, then the location suddenly becomes very interesting, right? Because if you're looking for a bike and you're located in Warsaw, probably you don't want to go get one that is in Poznan, like 300 kilometers away. So by doing personalization, we will learn that, oh, you looked at ads that were already in Warsaw. If you forgot to set the filter on Warsaw, well, we're going to catch that up for you. And we're going to push up all the bikes that are close to you. For Halloween costume, this is a really basic query, right? But you have tons of different Halloween costumes. And if you visit the day before some male clothing in M, then we can show you the Halloween costume that maybe corresponds better to your profile. Basically, here what we want to do is kind of replace the filters in those two. And the brake disc, well, that's going back to the golf example. If you already looked at ads that were maybe the brake caliper for a golf, if you just write brake disc, then we will guess, okay, you're looking at a golf or something like that. So we're hoping to help, maybe not solve every issue, but help with all of those by increasing accuracy. So mostly removing useless ads and potentially putting more promoted ads instead. Okay, so I went too fast. So now the question we had was like, how can we make it really cheap to try? And how can it be even cheaper to try it? And basically do it with one person in less than a month. So we decided to take only vectors for that. The reason is we already have vector search. So our Solar instance, it already has a lot of vectors. So we don't even want to try our vectors. The whole pipeline is already set up. All we want to do is basically collect the vectors from the search history of the user, make some aggregation that we are not completely sure about yet, but could be average for a start. And that will create a vector representing a user. And then Solr will take the role to compute the similarity between the user vector and all of the vectors we are looking at, all of the ads we are looking at. And from that, there will be one new feature inside the LTR algorithm. So what we have done in the past, we have done actually, based on feature engineering, we have done 10 minutes, thanks. We have done a very quick experiment with average price of the user, the favorite location, etc. And that gave us actually a 4% uplift in terms of meaningful interaction, just with features that we decided, honestly, in less than 10 minutes in a meeting around a coffee. So it was pretty good. I think the vectors are going to do better. We also didn't want any PII data just to save on cost and complexity. We don't want to know anything about the profile. That just would make things a lot harder. And we want to make it real time, because if you're looking for Halloween costume, chances are it's not going to take 5 days to decide it. You're probably going to buy it really quick. And this is what it's going to look like. So we have the click stream. It's going to be live. And then we have the quadrant. That's our vector server. So we fetch the vector for this given ad. We have a feature store that will log basically per user all of the ads you have seen within the past. That's not decided yet, but over the past few weeks, let's say. And then it serves the aggregation we want to have, and then Solr can take it and create the new features. That's what we expect. Just on the basic, very basic features, we got plus 4% uplift. And when we did the vector search experiment, we got 5% uplift also. Those were views. So we know our vectors are at least good, maybe not the best, but at least correct. And we know there is a lot of potential in personalization. So we don't have a data set yet, but that's why we made the guess that it would probably be worth it. All right.
Okay, so Ilan was talking about this y-axis, more responsible for pure relevance, and now we are in a business world, more in a business world, when the business has to be, it has to make money. So sometimes, you have such situation that business comes to you, and great. Your models are really nice, but there are more things to optimize for. And what's more, as soon as possible. So last 3 months, this is what we've been working on. So to come out to that problem, as I said before, we have vast types ads. So those with the, this is promoted or bump up ads that we refresh the creation of the ad and magically it's not on the top. But on some platforms, we have groups of users that pay more for posting than others. And those models that we trained before, sometimes they penalized those groups because like they found out that, for example, these are polished cars, basically buyers didn't trust those ads. So unfortunately, we had to help our business better distribute the core leads, the leads to the ads. So in this example, we have one group of ads, right? Let's say this is dealer 1, this is dealer 2, or group 2 and group 3. And our business said, okay, the whole traffic, let's keep it the same. I mean, let's the core leads number remain the same, but please distribute, right, those leads across groups in this weights. Circa, like we don't have to be precise, but please, like, get more traffic to group 2, right? For example. So yeah, we said, okay, but we have a multi-objective optimization. We could add more targets, but yeah, at some point we realized there are too many targets. It's too hard. And starting a new from the scratch, from the beginning, would be like a new project. So we had to kind of improvise in that sense. So we took our existing models, in our case, multi-additive tree models, and we simply added the weights of those groups to our tree. And we started checking, right, how the overall relevancy looks like versus the groups of the relevancy. And okay, so as you can see on this picture, we have 6 graphs, and the blue one, it's overall relevancy for all ads. This distribution here, it's a relevancy of the particular group. And by here, and we don't have any kicker value, so any weight. But going to the right, we see that the value is increasing, right? Here we have a maximum, there is none. And you can see how we move this group, distribution relevancy of this group to the right, right? So at the end, it's a bit higher. And now we can decide, right, where to place this group and also keeping the overall relevancy in the same level. And to train those models, the LTR framework helped us a lot because we had to train multiple models with the new weights. It was great that we had the past configurations for that, and it was just a matter of changing the configs instead of rerunning the whole pipeline sometimes. It was maybe not super easy, but yeah, we had to run several experiments, but also the whole process speed up because of that. But I think this is the most important, right? This business perspective here. It's super simple to explain how this works, right? And they can decide where we want to place these groups, right? Be more to the right or to the left, right? How much leads we want to generate. And at the end, right, the simple solution will go to market. And we want to thanks to our colleague that works with us, and basically he was the initiator of the presentation, but he couldn't be with us today because he broke his collarbone, unfortunately. But credits go to him. There is a blog post about LTR at OLX. And also we are hiring a lead data scientist. So if you want to work with us, that's great. Also in Germany. And yeah, basically, if you have questions, feel free to ask.
So questions?
Thank you for your talks. Really cool framework that you built. So you basically created this tool for the business, right? They can play around with the values. How did the business respond? Like, or did they like actually want to use a tool like that?
No, it's not like the tool is for business. It's for us, right? To train the models for the requirements of the business. Okay, so we can do those adjustments faster for the business, and business is quite rapid. I mean, dynamic, right? Those changes regarding targets, they are quite often.
And have you seen some long-lasting effects, like if the business changes its mind, that you cannot really use your previous data for training models?
It's still quite recent, right? As we say, we are working on those. We are not fully done on everything, so we didn't get to see that, but we will be looking at it for sure.
Thanks.
Any more questions? Oh, okay.
Were you able to, maybe this is not the right word, but educate the business thanks to this, explaining them that maybe sometime what they're asking for has a cost? Like, were your business users aware that this was a Pareto frontier and that improving one would come at the expense of the other? Or do you feel a tool like this or a project like this can help bring the technical knowledge to the business side?
So part of the framework tool, actually, for every model we have, we make a card that is supposed to be easy to read and that business picks up and understand. And then they never picked it up. So no, I think they understand the cost, but there's also like some teams that really want to push towards the more monetization and some teams that are actually asking the opposite. So there's always a big fight happening, and then we waited to settle until they tell us what to do.
So it's not a magic solution to conflict incentives in the company. Too bad.
I love that you talked about multi-objective optimization. I think that's something that we all need to think more about. So can I download this tool? I love that you built it, made it sort of as a joke, but I do feel like I've seen so many LTR projects go wrong because we treat LTR as like a feature or a re-ranker without everything around it, the explaining, the experimentation, everything else like that. And, I think I'd love to see that, the whole life cycle available. Very cool.
Thank you.
Thanks.
So thank you for the great talk. I didn't understand quite the part related to quadrant and solar in relation to vectors. Can you elaborate a little bit how quadrant fitted?
Sure. So basically, quadrant has the vector in the space we're interested in for every single ad in the platform. And when we get a click from a user, we just get the ad ID of that click. So we ask quadrant, please give me the vector for this ad. And then we store all of the ads you have seen within the past few days. And the feature store is doing the aggregation of those. So it's an aggregation of the vectors you have previously seen. And this aggregation represents a given user. Makes sense?
Yeah, but I didn't understand why not, for example, doing it entirely in Solar, for example, the vector management, or entirely quadrant.
Because we don't, like in our pipeline to store in the feature store, we don't want to use Solar. We want to use quadrant, basically. It's just more convenient. We have a dedicated team for that, and we can change the embeddings we want to use.
Okay, thank you.
Just convenience, basically.
Okay.
So, any more questions?
There's one at the back.
Sorry.
Yeah, thanks. Cool talk, cool stuff you're doing. Maybe a boring question, but multi-models, multi-objectives. So what about their management and maintenance? Starting from people towards business objectives, how do you deal with that?
Like, what do you mean? How to management of the models?
Yeah, so maybe two questions then. One, like let's say people capacity have, let's say 50 models, right? How things are breaking? Is it one people? How many people?
Okay,
so let's start with that.
So if you are more interested in the how we monitor those, in the previous talk in High Stack, we talked more about the monitoring part, and there we were describing Y-labs and Y-logs for our models. Unfortunately, Y-logs and Y-labs, they closed the business, even though Y-logs library still exists. We switched to Arise, and we are at the beginning with this tool. So what we monitor is basically our data set, how features change over time. So, but we detect basically simple things like if the feature produce data, right? So if there is a null value or not. Sometimes we rely on the drift but we don't actively monitor those. We rely on simple checks. For that, we use Monte Carlo in some of the data sets. And what else?
Yeah. This mic.
Business side.
Yeah.
Then we have business metrics like this number of core leads that we monthly generate, core leads per category, or successful events. Like we call them differently per unit. So yeah, we need to maybe unify the naming, but general business metrics, our analysts, they monitor.
Cool, makes sense, thanks.
Oh, so the last question then?
So thanks. Maybe I didn't catch it, but how many models are you maintaining right now? Because you mentioned different countries, different brands, different use cases, categories within.
For OLX alone, that was, I think, about 60 last time I checked. And in the verticals, so motors and real estate, that would depend. How many?
Free. In motors, it will be free. Real estate also free.
Okay.
So
okay, so you didn't go into the categories of each brand because they are pickups and vans and stuff like that. You didn't train models to optimize in that detail yet.
Sorry for interrupt your question. Like for general classified, yeah, we train models per category, right? In motors, still we are only in the area of private cars. We didn't expand to motorcycles or other categories in motors, but this is the plan, right? To go to scale up to different categories. In real estate, we're still exploring, right? Those categories.
Exactly. And also maybe I would add, I mean, sometimes there is no point in making several ranking models for different categories, especially when you do category browsing. Like that one, it makes sense, but when it's keyword search, it doesn't always make sense because we don't know the category you're looking for when it's just keyword.
Thanks.
Thank you.
So thank you for your talk. Let's applaud.